Welcome to the Introduction to Stellarium module. Stellarium is a free, open-source planetarium program available for most platforms. Please see the separate text file explaining how to access and install the software. In this module, you'll become familiar with the basic functionality of Stellarium, though I will ignore the time domain. The time evolution of the celestial sphere will be discussed in some detail in both the horizon and equatorial coordinates modules. To prepare for this introductory module, you should have already viewed the celestial sphere module, in which many of the concepts that will be noted here were introduced. Let's begin. What do you see before you? In this view of my screen, you see a blank sky above what appears to be a static ocean. The horizon appears flat. You also notice a four-paneled menu in the upper right. We'll ignore this menu since it's intended for nighttime observers. There is also a line of information at the bottom of the screen. As you can see, the observer is situated on planet Earth at the location of New Orleans, Louisiana, in USA. The field of view, FOV, is just over 90 degrees. The third number is not important for our purposes having to do with hardware parameters. But the rightmost field gives the date and time at the location of the image. Now I've stopped the time to be around noon local time on what it turns out to be American Thanksgiving, November 25th in 2021. As noted in the introduction, we'll deal with the dynamic celestial sphere in a later module. But it's important to note here that time is always given in the 24-hour format, and that astronomers always work in standard time, not daylight savings time. The rightmost number shows that the time zone is 6 hours behind universal time, UT, the time recorded on Earth's prime meridian. Moving the cursor down towards the bottom of the screen reveals a host of other menu options, many of which we'll be learning about in this and following modules. There is also a menu that can be accessed by bringing the cursor towards the left side of the screen. These are used to set some of the initial conditions for the display. The three most important, at least for our immediate concerns, are the location window, which is used to set the location of the observer, the date time icon, used to set the date and time unsurprisingly, and the sky and viewing options window, which is used to set a variety of important parameters that we'll now address. On clicking on the sky and view options, a window pops up with a number of further menu options. Click on the leftmost option, Sky. The bottom of the window lists a particular projection of the display that has been selected. Perspective. Recall that the celestial sphere is inherently three-dimensional, but our display is only two-dimensional. In order to visualize the portion of the celestial sphere before us, a projection algorithm must be selected. As we've noted, the horizon appears to be in the perspective option. While this might seem reasonable, that is a flat horizon, this projection leads to a variety of odd effects on the sky we're about to explore. Now feel free to try a variety of such projections on your own time. Some are wild. Now I'm partial to the Hammer-Atoff projection. Why? First, it has the coolest name of all, Hammer-Atoff. Second, it preserves area, though does not quite preserve angles. Before we exit this window, saving the parameters, clicking on the X in the upper right-hand corner, I wish to change the horizon display. So clicking on Landscape allows us to do this. We notice it's first set along ocean. Note that ocean setting can be used from any location. From New Orleans, this could represent the Gulf of Mexico, but we could also use this landscape option from the middle of the Sahara Desert. Again, feel free to explore various horizon options. For our purposes today, I prefer the zero horizon option near the bottom of the left-hand menu. So click on that. Now exit the sky and view option. Now we see before you that the horizon is now curved, the hammer ATOF projection, and the ocean and intervening Earth have turned solid green. Let's play with the horizon using keyboard shortcuts. There's a list of keyboard shortcuts that will be provided for you. Now typing a lowercase g, as I'll do now, once, makes the horizon transparent. In other words, it disappears. Typing it again restores the horizon. Now with a transparent horizon, in other words, typing G a third time, type the lowercase h. This leaves the horizon as a thin green line with an appropriate label. Let's bring up the compass points now to show the direction we're facing. To do this, we can type a lowercase q. Notice that the southeast, south, and southwest directions are indicated along the horizon. By the way, we could also turn on or off the compass points using an option from the bottom menu. How do we navigate around the horizon? Stellarium makes this easy. You can instantly and accurately go to one of the cardinal points, north, south, east, or west, simply by typing the uppercase letter. For example, W to face west. Capital E to face east. Capital N to face north. And capital S to face south again. You can also use the left and right arrow keys to move east and west along the horizon respectively. I'll now hit the left arrow and that will move us counterclockwise along the horizon. The right arrow will move us clockwise around the horizon. Typing capital S will once again direct our view due south. It would be helpful to see a few of the most important configuration points on the celestial sphere, in particular the north and south celestial poles and zenith and nadir that we learned from the celestial sphere module. To do this, we need to select Sky and Viewing options again on the left-hand menu, and then Markings from the top menu. We make sure that the celestial sphere option is checked, and we see that the cardinal points and horizon are checked because we already turned them on from keyboard shortcuts. So we're now going to turn on the celestial poles and zenith and nadir configuration points. Explore more of these options as you become more familiar with the night sky and these parameters. Let's exit the window and now face north, capital N. We notice that the North Celestial Pole, NCP, has come into view. How about the zenith? Well, it's not on the display, but by using the up arrow, we can view higher and higher altitudes. A couple of clicks will bring the zenith into view. There we have it, a capital Z or Z with a plus sign. Now we hit the down arrow a couple of times to return to the previous orientation. One can use a capital Z or capital Z to immediately access zenith, but this causes a few extra problems I don't want to deal with, but please explore this on your own time. How about the South Celestial Pole? Well, we know we have to face due south first of all. Fortunately, we have a transparent horizon, so by using the down arrows, we should eventually come to the South Celestial Pole, SCP. Let's do that now. And there we have it, the South Celestial Pole, SCP. By the way, you can always zoom in or out, that is, decrease or increase the field of view by using 2 fingers up or down on your touchpad. There are also keyboard shortcuts for this, but I prefer 2 fingers and then swipe up. Notice how the field of view at the very bottom is now 185 degrees, a lot of compass points, or we can go field of view down below 70 degrees here, swiping down. I'll try to recover around 90 degrees and down arrow, an up arrow to get us back to our original perspective. Now I'd like to change the observer's location from New Orleans to Edmonton, Alberta, Canada. Nothing against the Big Easy, but it will be helpful to learn how to set the observer's location. This time, we select the location window at the top left menu. First, notice the bottom half of this window. It provides the latitude, longitude, and elevation of the observer's current location, New Orleans. To change location, there are 2 options. Stellarium has a number of locations already pre-programmed. The first few entries in alpha order here can be seen at the top right. We, however, can type in Edmonton, Canada to see if in fact it is in Stellarium's database. And in fact, as you can see, it is. So we click on Edmonton, Canada, and notice that the latitude and longitude and elevation have changed appropriately. What if our preferred location is not in the database? Well, not a problem. Simply change or edit directly the latitude and longitude to set your needs. So you can use the up or down arrows in each of these different cells, or simply type in the latitude and longitude, degrees, minutes, and seconds explicitly. This is very helpful when you wish to explore the celestial sphere from places not in the database, such as the North and South Poles. Now exit the window and face north. Capital N. Notice that the North Celestial Pole is much higher in the sky, reflecting the higher latitude of Edmonton compared with New Orleans. The most important great circle on the sky is the observer's meridian, the line on the sky that effectively divides the east side of the night sky, to the left, from the west side of the sky, to the right. Recall, the meridian is the great circle that includes the observer's zenith, North Celestial Pole, South Celestial Pole, and nadir. So let's plot the meridian. We do this by typing semicolon. The labeled red line certainly passes through the North Celestial Pole and North Cardinal Point, as it should. How about through the South Cardinal Point? So let's face south, and we see it in fact does pass through the South Cardinal Point, and in fact we can demonstrate it passes through the South Celestial Pole as well. How about the zenith? Does it pass through the observer's zenith? Well, by using the up arrows, we can confirm that, in fact, it does pass through the observer's zenith. A word about directions. We've just noticed that on the celestial sphere, east is to the left and west to the right. Is this not inconsistent with directions on land maps? No, these are entirely consistent if you think about it. In the case of land or street maps, we are looking down on Earth's surface, so east is to the right. In the case of the celestial sphere, we are looking up, east is to the left. Let's do a thought experiment to illustrate this better. Imagine we're transported to the center of a hollow Earth whose surface is made of glass and on which the continents are drawn. Look up from your position at Earth's center to New York and Los Angeles in North America. Now, New York is to the left and LA to the right, even though New York is also east of Los Angeles. It's all about location. Another important great circle on the sky is the celestial equator. To turn this on, type comma. Sure enough, a labeled great circle appears on the sky. The celestial equator must always pass through the east and west compass points of an observer's horizon. Let's confirm this. Let's face east. Yes. Let's face west. Yes again. Back to south. The last great circle to plot in this module is the ecliptic. Recall, the ecliptic is the extension of Earth's orbital plane, really the Earth-Sun orbital plane, to the celestial sphere. To show the ecliptic, type comma. A labeled orange great circle appears. Recall, the sun moves exactly along the ecliptic throughout the year. The planets follow very close to this path as well. Speaking of planets, let's make the planets appear by typing lowercase p. There are 4 bright objects whose identities we can obtain by typing Alt-P. So we see here Mars, Mercury, the Sun, and Venus. Notice that the Sun and you'll see Moon appear with the planets when you type P, and the Sun is designated by a small circle that appears less bright than some of the other planets. Now, this is for practical purposes. You've likely noticed that the Sun's light has been turned off as we're examining the daytime sky from our location. This is, of course, a very helpful feature, but we can turn on daylight by typing A for atmosphere. So here I go, lowercase a, and virtually everything else that we haven't drawn disappears. Not helpful for our purposes today, so let's turn off the atmosphere and the sun's daylight. Let's take a look around the sky to see where the other planets are situated at this time. I'm simply going to use the left arrow to move along the horizon. So we see that Saturn has come into view, along with Jupiter. I hope you can read these very small on the screen. We see Uranus come into view. And then the Moon comes into view. Notice it's slightly above the ecliptic, since Moon's orbit is tilted just over 5 degrees with respect to the ecliptic. And finally, we return to original orientation, which I'll obtain exactly by typing capital S. Let's now turn off the planets and their labels. We type Alt-P to remove the labels and lowercase p to get rid of the planets and sun and moon. It's time we populated the celestial sphere with stars. We can turn on the stars using lowercase s. Stellarium has an extensive database for a considerable number of stars, their location on the celestial sphere, and their brightness. The colors of the brightest stars are even reproduced reasonably well. The names of the brightest stars can be turned on using Alt-S. And notice that particularly for the brighter stars, some are white, some are blue, some are orange and reddish. The color of a star, as you'll learn in your astronomy course, has to do with the temperature of the surface of the star. Facing north, that is capital N, we can see that there is a star very close to the North Celestial Pole. Now, most of you know that this star is called Polaris. It's within a degree of the North Celestial Pole and has been a boon or a great advantage to seafaring cultures over the past few centuries. Now, why doesn't Polaris have a label? Because the brightness limit I'm using for the printing of labels isn't faint enough. There is a slider bar in Stellarium that will allow you to set the brightness limit for labels. So, slide over to the Sky and Viewing Options window on the left-hand menu. The Sky option from the top left. And this is the slider bar I was talking about. If in fact you move it to the right, you can see lots and lots of labels appear for fainter and fainter objects. And if you move to the left, in fact, only the very brightest star labels appear. So we'll move it back to roughly where I had it, and then exit. One way of confirming the identity of a suspected star is to move your cursor as close as you can to the star itself and then left click. And in fact, we then see that this indeed is Polaris, accompanied by a number of other names in different cultures and catalogs. There's a variety of information here, that some of which will make sense of, even in this module, but particularly in other modules. To remove the information, simply right-click anywhere on the screen. Now this is very helpful because it's easy to mistakenly left-click on the screen as you experiment with Stellarium, something I strongly advise you to do. Now let's conclude by using some other options from the bottom menu. First, turn off the celestial equator and ecliptic, period, comma. Then go to the leftmost icon on the bottom menu. Clicking it will show stick diagrams of the constellations. As you know, the International Astronomical Union, the IAU, has divided up the entire celestial sphere into 88 constellations, just like the number of keys on a classical piano keyboard. If you're like me, these stick figures aren't that helpful for identifying most of the constellations. No problem. Let's click on the next icon, which conveniently labels the constellations, much better for my purposes. The third icon is also helpful, showing more artistic visualizations of the constellations. The constellations through which the sun passes annually is called the zodiac. Let's bring up the ecliptic again with a comma. You see here some familiar sun signs, zodiacal constellations. We have Libra, Scorpius, Sagittarius, Virgo, etc. Feel free to take a tour around the horizon to identify your sun sign. A couple of comments. Most people wrongly believe that the sun passes through only 12 constellations during the year. That's what horoscope columns tell us, but this isn't true. The sun passes through a 13th constellation, at least according to the IAU. Which one is it? Second, the constellations of the zodiac, which the sun occupied at a particular time 2 millennia ago, during the time of Claudius Ptolemy, are different from today. This is due to precession, something you'll learn about in your astronomy course. I'll illustrate this by turning on the planets and sun, lowercase p. Here's the sun, Alt P to confirm that. And you notice that is in the constellation Scorpius. But people born on November 25th are Sagittarians. This illustrates both the effects of precession and provides you with enough information to make your next conversation with a friend who believes in astrology or your personal astrologer that much more interesting. This concludes the module on the introduction to Stellarium. In the next module, we will learn the horizon coordinate system that builds on this module and that of the celestial sphere.